और टॉपिक से निकलने ऐसे होता है उसको पता नहीं है तो मेरा भूल गई
जाते वक्त लेके जाओ हमारा छाता वगैरह और 2 3 4 वर्ष में शायद नहीं ज्वाइन किया है तो तुम लोगों ने कई टॉपिक वगैरह मिस किया है एग्जाम में फुल एग्जाम करके है और तुम लोगों का 3 तारीख से है तुम्हारा तुम लोकमान्य तिलक हम लोग तुम लोकमान्य तिलक और हमारा 3 तारीख से नहीं कभी तक है पता नहीं अरे एटलीस्ट शेयर तो करो ना मेरे साथ मेरा नंबर तो तुम लोगों के पास है और तुम लोगों का सोचा फर्स्ट जुलाई टू we have finished the portion और तुम्हारा भी
not in English but others we have but not in English
10 तारीख तक है अच्छा उस समय पे आप आने वाले हैं या नहीं आएंगे इधर और तुम मुश्किल नहीं तो तुम्हारा एग्जाम टाइम तुम आने वाले हैं देखेंगे और तुम्हारा एग्जाम एंड ऑफ जुलाई को रहता है तुमको तो मैं हेल्प करूंगी क्योंकि टीचर्स भी अवेलेबल हो जाते हैं और तुम्हारा भी एक्स्ट्रा लेक्चर में हेल्प करूंगी और इनको उतना नहीं हो रहा है 3 तारीख का 3 तारीख का आप अगर मैथ्स छोड़ के बाकी कुछ हेल्प चाहिए क्या सब्जेक्ट में मैथ्स एक छोड़ के मैथ्स में आगे नहीं हो रहा है 7 तारीख के बाद ही हो जाएगा मैथ्स का भी है हमारा रोहन किसका है क्या बोला
Hello everyone. Where did we stop in the last class? कहाँ पे रुके थे? और एक न्यू एडमिशन वेलकम। तो इतना बहुत जगह है, आगे पीछे होके बैठ जाओ। आगे आओ, आगे पीछे क्यों जाओ? Pascal's law. So, we had started pressure. Okay. So anybody remembers what is pressure? बताओ. What is pressure? Force, just force, or force acting for unity. So is it force or thrust? Pressure is thrust per unit area. Pressure is thrust acting for unit area. Now, what is the difference between thrust and force? Both are same, but still, then why are we calling it thrust, not force? Yes. So perpendicular force. Perpendicular force acting on the surface is called thrust. Okay. So then we learned about pressures in case of liquid. So what did we learn? What are the characteristics of pressure inside the fluid? Did I tell you what is fluid? Fluid I told you. Okay. So what happens to pressure inside liquid at different points?
Increases with depth.
Yes. So pressure increases with depth. What is the formula for pressure in liquid? H rho G. Okay. The depth into the density of liquid into gravity at the place. Okay. So this formula I don't think is given in the book, but in the volume it is given, I think. Okay. So pressure depends on these factors. The other formula for pressure we saw was thrust upon area. Okay. These are the two formulas for pressure. So we saw that it increases with depth. Then is it a scalar quantity or vector quantity? Pressure is vector quantity?
Scalar.
Scalar. Why? Because it is not vector, therefore scalar. Scalar teacher. Why it is scalar? It acts in all the directions. At any point inside the liquid, pressure at that point acts in all directions. So does it have a fixed direction? No. But a vector quantity has a fixed direction. Okay? That's why pressure is treated as scalar. So, like inside liquid, let us say this is the liquid here. So at this point, pressure will act in all the directions. Okay? So it doesn't have a unique direction. That's why it is called scalar quantity. So with depth increases, what about pressure at the same level? At same depth? Will it be same or different? Huh? It is same. Okay. So these are some of the things that we learned. How did we say that pressure is same? So if we drill a hole here in the vessel, so you will see that it throws the jet of water at the same distance. That means at the same level the pressure is same, right? Now if you drill it over here, you can see that it is throwing at a greater distance from the base. That's why as the depth increases, pressure also. Okay, what else did we learn about pressure?
The density of the
So if we replace water with honey, honey has what? More density. So at the same point, at the same depth, now the pressure will be more. Okay? All these things we learned. What else? Did we do this numerical also? We did this numerical. Okay. So then Pascal's law. What was Pascal's law? Let us say we apply, if we close this with the help of a piston. Okay, like a syringe. Okay, injection syringe. Now when I apply force here, right? So force per unit area will become pressure. So some pressure is applied here. Let us say I'm applying some pressure here, right? So this pressure will be added at every point. Okay, let us say here pressure was PA. When I apply pressure from outside, the pressure here will become PA plus P. Okay, let us say this was some point, let's call this at point E. Pressure here was PE. So here also P only will be added. Same pressure is applied at every point inside the liquid. This is Pascal's law. Okay, so more details about Pascal's law is not there for you. Did I state what is Pascal's law?
Yes.
What is the Pascal's law statement I have given you?
pressure applied at any point in the container is transmitted equally.
Equally undiminished. Okay, so that's Pascal's law. So where do we use Pascal's law? It is used for building hydraulic lift. Is used in so hydraulic lift. Can you give me an example of hydraulic lift? So car service stations, have you visited?
Car parking.
Yeah. Yes, that is also hydraulic. Okay,
So.
so car parking is also in some way. Hydraulic bridge is also, yes, wherever. So basically what happens is, have you seen, let us say this is the platform, okay? This platform on which car is, let us say this is the back side of the car. It is kept on the lift. So where is this lift? Right, so this is connected to some other cylinder like this. So there are two cylinders with different area. Right?
When they have max pulling differently.
So when a pressure is applied here, whatever pressure is applied, the same pressure is transferred over here. Okay. So here the area of cross section is A1. Here the area of cross section is A2. Right. So this pressure, okay, will exert force FA over here. FA. What is pressure? Into A1. So how much force is acting on this cylinder? FA. Now here some different force will act. Let's call this as A2. So let's call this as FB. This is cylinder A and this is cylinder B. Okay. So what is FB now? FB will be equal to same PA will go here also. Whatever PA, right? So this will be PA into A2 now. Right? So what is it now? So take the ratio. So you'll get FA or FB upon this is PA. PA and PA will be cancelled. FA upon A1. So how much is FB? FB will be equal to A2 by A1 times F. I'm just giving you an illustration. It's not in your syllabus, right? So will FB be greater than FA? The force generated on the second piston, will it be greater? Yes, because area A2 is greater than area A1. So you can design this platform. Let us say you want to multiply the force 10 times. So this piston area you can choose to be 10 times of the first one. That's why you must have seen the operator just taps slowly here. If it taps here slowly, and this will just go on up. Okay, so small force gets converted into bigger force. So this system acts as force multiplier. By applying a small force, you are generating a bigger force. And how to, what is the multiplier? That you can design. Okay, so if A2 is 10 times A1, the force becomes 10 times. If A2 is 100 times A1, then the force, whatever force you are applying, if you are applying 10 Newton, it gets converted into 1000 Newton. Okay, it will be 100 times. So this is how you build a machine. So this is the application of Pascal's law. Same pressure is transferred, but it gets converted into a bigger force because that pressure is acting over a larger area. So it gets converted into bigger force. All right. Now this brings us to the last topic, which is buoyancy and buoyant force. Let's understand this. Till here we did in the last class. Any idea what is buoyancy? So if you try to submerge a ball inside water, will it submerge or float? So when you forcibly put it inside water, and when you remove it, the ball it again comes up. A ball or any bottle also, plastic bottle. Yeah. So why it happens? Even when you enter into a pool, what happens to your body weight? You feel lighter. You feel like you have lost weight inside water. Don't you feel so? So why it is so? So every fluid has a property to exert upthrust whenever you try to submerge object into it. Okay? So fluid has a property to exert upthrust on the objects that are submerged in. Okay?
1 feet.
That are being submerged in. So any object you try to submerge inside liquid tries to throw it up.
Sir, lemon.
What level? That will also float. But what about a metal block? Will it float? Okay. So not all objects will float. Some will sink. So we have to now learn what will sink and what will float. Okay. So let us first understand what is buoyancy. So fluid has a property to exert upthrust on objects that are being submerged in it. This property of liquid is called buoyancy. And the upthrust exerted is called buoyant force. Okay, upthrust is also a force only, right? So this is called buoyant force. Okay, so like if you have something right? So when any object is submerged inside liquid, okay, so you'll experience buoyant force. So this is center of gravity. This is where the buoyant force is acting. Okay. So what is the weight of the object? It will be mg minus the buoyant force. That's why the weight of the object reduces inside the liquid because of the upthrust. So buoyant force F3. Okay, let us say we have denoted it well. This is the reason why the weight reduces inside fluid. So mg is the weight. Which weight? Apparent weight. So you call it W dash. W dash is the apparent weight. In the So fluid means liquid or gas, right? That's why the parachute, it experiences buoyant force. That's why it does not suddenly come down. Okay. So it is the buoyant force because of which it comes down gradually. Right? So principle of flotation. Let's understand flotation. So which object will float? If buoyant force is equal or greater, only those objects will float. Isn't it? If the buoyant force is equal, then it will hold the object up. Right? So it should be greater than or equal, then only the objects will float. Okay? So this that is given by what is called as Archimedes principle. Okay. What is Archimedes principle? There. So how much is this buoyant force then? चलो वो कर लेते हैं. The buoyant force acting on the object is given by Archimedes principle. Archimedes Archi. So it will be different because you will see what is Archimedes principle. It says that states that buoyant force acting on the body is equal to the weight of the liquid displaced by the body by its submerged force. Like this much part of the body which is inside the liquid, before the body was pushed, it was occupied by water. That water is displaced. So the weight of that water is the buoyant force. Okay, that's Archimedes principle. Okay. Which is weight of the displaced liquid by the submerged portion of object. Who experiences buoyant force? The submerged object. So buoyant force is equal to the weight of the displaced liquid by the submerged portion of the object. Okay. So this is the principle. So for objects to float, which object will float? Weight of the object must be less than buoyant force. Okay, weight of the object must be less than buoyant force. So what is weight of the object? It is mass of the object into gravity. And this will be nothing but mass of the liquid into gravity. Okay. So when the object is fully submerged, right, the buoyant force also will increase because it is displacing more and more water or liquid. So for a fully submerged object, yeah, what is that? Mass is volume into density. This is so if the object is fully submerged, the volume of water or liquid displaced will be same. It will be equal to the volume of the object, isn't it? And gravity is same on both sides. So ये तो खत्म ही हो जाएंगे, है ना? That's it, खत्म हो गया. And V also gets cancelled. So all those objects whose density is less than the density of liquid will float. This is the condition for flotation. Thus, objects with density less than density of liquid will float. ठीक है? तो कौन फ्लोट होगा? इसका डेंसिटी लिक्विड की डेंसिटी से कम है, इसलिए मेटल विल नॉट फ्लोट. फिर वाई शेप फ्लोट. Ships.
Because the surface equals the.
So what happens?
So the force gets divided and then.
So basically, for flotation, this is one, and this is also the thing, right? Weight of the object should be less than the upthrust. And how much? What is upthrust? It is equal to the weight of liquid displaced by the submerged portion. That is Archimedes principle. तो शिप के केस में क्या होता है? So let us say, let's say this is the submerged portion of the ship. फ्रंट व्यू दिखा रहा हूं. तो वाटर तो फुल वॉल्यूम पे डिस्प्लेस किया ना उसने. This is not a solid bed. So metal is only the outer part, only this part. Inside is air. This is air. But full volume of liquid was displaced. So weight of the liquid displaced is much higher. then just this part, or even the full ship weight. Okay, so the upthrust generators is much higher than the entire weight of the ship plus all the contents of the ship. Water is heavy, right? Water is displaced fully, but it is not full metal, it's not solid metal, it's hollow. So the average density of the submerged portion of the ship is less than the density of water. That's constant. Okay. So this is all we had to do in this chapter. A nail will sink. Nail. What did you hear? Mail. Okay. इसका mail आने वाला है क्या फिर? Nail is a metal. This will sink. But a ship doesn't. Okay? Because it is displacing a lot of water. Its weight is resulting into a very big upthrust. ठीक है, जबकि nail sinks में ऐसा नहीं है, इसका density ज़्यादा है, sink में. Clear? So just go to it. अगर nail अगर sink हो रहा है तो iron ball भी वही है, solid है ना, hollow iron ball नहीं हो.
All objects don't sink, but the objects is
Wait. Buoyant force should be greater than the weight of the object.
It is hollow, the weight is less.
Yeah, because inside is air, no? It is a hollow ball. इतना बड़ा तो मैं solid ball ले लूं, उसका weight बहुत ज़्यादा होगा. The buoyant force generated is same in both the cases. Suppose this is a solid ball and you have a hollow ball. ठीक है, दोनों को तुमने अंदर डाल दिया. So buoyant force is same only because that depends on the volume, no? Submerged portion. So water displaced by both ball is same, but this buoyant force will be able to sustain this, but not this weight. इसका weight ज़्यादा है. Got it? Yes, sir. Just sir, I thought you were in a shock. ठीक है ना? ये air है यहाँ पे. This is full metal, solid metal. ठीक है ना? FB दोनों में same हो रहा है. ठीक है? Okay. Now there is an experiment given by which you can also measure the buoyant force. You can measure buoyant force experimentally also. One is through Archimedes principle. How will you measure through Archimedes principle?
The liquid
Weight of the liquid displaced. How much liquid is displaced?
weight of the
Which is equal to the volume of the submerged portion of the object. So volume you calculate. Then you need to know only the density of the liquid. To calculate its mass. Multiply that by G, it will be weight. So theoretically you can do it by Archimedes principle. You can verify that with this experiment. So what you are doing is, there is a beaker full of liquid, okay? So first you suspend the object in air and note the reading. That will be weight in air. So that's the weight of the object actually, right? Now raise the platform. Let's say there is a platform which is like, you can change the height of it. Now raise the height of the beaker full of water so that now the object is fully submerged in it. Now make the reading here. Now you will see the different weight. Okay? Because now what you're getting is apparent weight. So W1 was weight in air and W2 is weight later on. So this must be the difference must be the buoyant force. Okay. So whatever is the difference in the weight must be the buoyant. Got it? W1 is weight in air. Should I do it again? Measuring void force experimentally. Okay, so yeah, so whatever is the reading here, that reading is W1. Okay, that reading is W1, weight in air. Now you suspend the same object inside. So spring balance will measure the weight for you. So now what it will tell you is W2. Okay, because now the upthrust buoyant force is acting on it. Weight is downward, so W2, right? So what is W2? FB. How much will be W2? W1 minus F. So this gives us FB is equal to W2 you can measure experimentally. Whatever weight shown here is W2. So FB will be W1 minus W2. Weight of object in air. Where is weight of object in air. And W2 is weight of object in liquid. Both weight you can measure experimentally. Take the difference. That is FB. And it will be equal to the weight found by the Archimedes distance. Archimedes distance. Okay. So laws of flotation covered.
Yes.
Which body will float? Whose density is less than water. Which body will float in water? Because for us, mostly when we are sailing the ship, what kind of water we have? Sea water and fresh water, river water. Okay. So where the level of the ship will be more submerged, sea water or river water with the same load? Are you getting the question? Let us say a ship is loaded with the weight of the ship does not change, right? Let's say W is the weight of the ship. It is sailing in river water. Now it is entering T. So will it be submerged at the same level as river or it will go up or go more down? Go up. Why?
Because the density is more.
Of
Fresh water.
fresh water density is more.
No. Seawater.
So sea water will exert bigger upthrust. Okay. Okay. So this is what it is. All right. So with this, we have completed the chapter. Now there are some applications. Where do we use this flotation? Principle of flotation is used in designing ships and submarines. Okay. Then there is lactometer and hydrometer. Lactometer is to check the purity of sample of milk, right? Hydrometer to determine the density of liquid. So you just know these things. How and more details are not needed. Just know this. Lactometer to check the purity of milk. So this is due to difference in the densities of milk and the liquid inside the meter. Okay. And likewise, you have hydrometer. Okay.
How can we see the purity of milk?
Because for pure milk, the density is measured. So if the milk is dilute, listen, if the milk is dilute, then obviously its density will be less. So the lactometer will submerge more when it is not pure. Okay. Density will change if you fiddle with the purity. Everybody understood? So more details not required. Lacto, something to do with milk. So lactometer and hydrometer. Okay, now we have what kind of questions there? So are you doing the activities from your NCERT textbook? Huh? Yeah, no. What did you say? No? Okay, so read now. So read all the activities and ask me questions wherever you don't understand. Read. Cover all the activities given in the book. Many questions are activity based. Okay. So let's discuss the questions. Once you have read the activity. So first activity you have already covered in previous chapters. Okay. So next, there are no questions there, just the observation and conclusion. What about the second case?
Sir, may I go to washroom?
What do you understand from the second activity? Is the buoyant force acting same in all situations? How can the buoyant force be same in all situations? Is the buoyant force same in all situations when the bottle is pushed inside the water? It's written there. The bottle is being pushed inside the water, right? So there go. So let us say you have
What is the density of the fluid and the mass of the object both are same, but the force applied by us is different, so the point for is here.
let's say in the first when you leave the bottle here, okay? with the cap closed, it will float like this, right? Now you force it down. You applied some force. So here some buoyant force is acting here. Let's say this is F1. In this case, will the buoyant force be same or will the buoyant force be same or greater? Same. How much is the volume of liquid displaced here? And how much is the volume of liquid displaced? Very little, maybe, just on the surface. So what is the buoyant force as per Archimedes principle? What is the buoyant force? Read the Archimedes principle. Did I give you the Archimedes principle? So where is the weight of liquid displaced more? In the first case or in the second case? Second case. So this is Fp dash. This is greater than the first case. Now when it is fully submerged, this will be Fp double dash. So what is the relation between all this? Understood? Archimedes principle. The weight displaced in three scenarios is different. Okay? In this case, the maximum volume of the liquid is displaced. What's so funny? Huh? Huh? Shakal.
I was reading it.
So, again, I moved to crack joke or comedy. What are you doing? Also, read for yourself. Have you understood the concept?
Yes.
So, in all three cases, the buoyant force is different. Because here, the force applied is, in this case, the only weight is the weight of the bottle. What is the, let's say the weight of the bottle is W. Here it is W plus F. Here it is W plus F double dash. And all of it is balanced now. Because you have to force it and hold it there. Otherwise, if you leave the bottle, it will come here. So the extra force applied is holding the bottle inside. Understood? It's very, very clear. So if you like press the bottle and keep it like this, that two bottle will be staying there because you are holding it. That force has to be accommodated by buoyant force. So very logical. Okay? So it's not like increasing just like that. The more volume of water is displaced. That's all. Is the activity clear? This experiment you can do at your home also. Take a empty PET bottle, water bottle, and you can check this out. Okay, read the third one. Everybody for yourself. It's a very central. छोटा पैकेट में बड़ा सामान है तो की तो बहुत चली मेरे लिए कुछ सोचना पड़ेगा मेरा इलाज सोचना पड़ेगा So activity number 3. अभी क्या है नहीं आ रहा है भाई ढंग से करना कि काम की छूट होगी है बच्चों को ये बोल के नहीं लाया कि बहुत बढ़िया काम भी करना पड़ता है, बोलने में ठीक है। क्या बोल के लाया तुम लोग ये? बोलो क्या? Okay, so third activity में कोई problem है? This is very clear. So why cork floats while nail sinks? दोनों का mass same है. Because due to difference in density, weight depends on density. देखो mass same है तो भी क्या अलग है? Density अलग हो सकती है. So the average density of the cork is less because cork is porous. So it has air also inside. Fourth activity. So fourth activity is very similar to the experimental determination of point force. Same thing. Okay. Because it is only mentioning spring balance but not shown there, which we did in this section. Alright.
It reduces naturally in the poles and posters.
Yes, the apparent weight reduces. The actual weight remains what it is, but due to buoyant force acting on it, so spring balance records apparent weight when it is submerged in water. Okay. So with this, where is the class for question here? Most of the textbook questions are solved, not there. 38. Okay, so let us do classwork questions. So define the weight of a body. Now these are review questions, right? Weight of the body. Define. First you have to define what is the weight of the body. How do you define weight of the body? By Earth's gravity. Weight of the body is nothing but force exerted. So good opportunity for people who missed the initial portion of this chapter. Weight of the object is nothing but the gravitational force exerted by Earth on the object. How much is that? Mass of the object multiplied by acceleration due to gravity, as per Newton's second. Correct? Which is g, mg. So always weight of the body is always mg. What is acceleration due to gravity? What is acceleration due to gravity? The acceleration developed in the pen when it is dropped. So any object which is under free fall, okay, the acceleration developed by the object under free fall is the acceleration due to gravity. Okay, so the acceleration. Pressure, force per unit area, right? Or thrust per unit area. What is thrust? Normal force or perpendicular force acting on the surface is thrust. Density of the substance is the mass per unit volume. Okay, is the density of the substance. What is relative density? That is now removed from your syllabus. But relative density
It
is.
doesn't have a unit.
Huh?
It doesn't have a unit.
It doesn't have a unit, but what is relative density? Relative density is density of the substance divided by density of water. How do you define relative density? Ratio of density of the substance. So it is relative density of the substance. It's the comparison of the density of substance with respect to density of water.
Density will be cancelled.
Huh?
Density will be cancelled.
So that it has no unit. That's why it has no unit. Density by density is just a number. So if I say mercury's relative density is 1.3 or 13.3, how much is that? Relative density of mercury, will see somewhere. So if I say relative density of mercury is 13.3, it means it is 13.3 times the density of water, which is how much? Any idea what is density of water? Density of water you all must remember. It is 1000 kg per meter cube. This is the density of water. Okay. So density of mercury will be 13.3 times density of water. Let me just check how much is density of mercury. Yes, it's almost the same. 13.3. Okay, kg per meter cube. Okay, so they are quite close. All right. So, what is buoyancy? Liquid to exert upthrust on the body. Yes, very good. Now, what is Pascal?
Unit of pressure.
Yes, Pascal is unit of pressure, which is how much? F by A, Newton per meter square. Okay, 1 Pascal is 1 Newton per 1 meter square. State universal law of gravitation. Universal law of gravitation. Pass to your best friend. Universal law of gravitation. What's the law? Every object in the universe attracts every other object in the universe by a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. यह है तुम्हारा यूनिवर्सल लॉ ऑफ ग्रेविटेशन. मतलब मैथमेटिकली क्या है? F is equal to ये. And when you remove the proportionality, it becomes this. So this is true for any two objects in the universe. Okay? So that is the universal law of gravitation. What is meant by free fall of a body? You know that. When the object is falling down only under the influence of Earth. अब जैसे कोई रॉकेट ऐसे जाने की बजाय अगर ऐसे आ रहा है तो वो अर्थ ग्रेविटी की वजह से फॉल तो हो ही रहा है प्लस देयर इज अ फोर्स वो फ्री फॉल नहीं होगा. When the object is falling only under the influence of Earth's gravity, then it is free fall. Okay? So in free fall, two motions are possible, both upward and downward.
Which one is positive? Which one is positive?
Which one is positive? In what sense positive? G positive or which what positive?
Directly.
Direction to this is positive.
Positive J का form.
देखो, so it's relative. When the acceleration due to gravity is in the direction of motion, then G is positive. When the acceleration due to gravity is opposite to the direction of motion, G is taken negative. But G is always pointing downward, irrespective of the direction of motion. Okay, so question has some conditions.